Welcome to VISENGI's video broadcast demo. This system demonstrates many of VISENGI's IP cores: JPEG encoder and decoder, Ethernet, DVI and HDMI input-output interfaces, and a gigabit UDP/IP network stack. The system input is a PC at the left, with two clone DVI or HDMI outputs, both at 60 frames per second Full HD. The first output goes directly to the left display. The second is sent to the encoding system FPGA. This FPGA contains a DVI HDMI input interface and 4 hardware JPEG encoders working in parallel. They allow a constant encoding throughput of 265 megapixels per second or two 1080p 60 streams. An external DDR2 image frame buffer has been used, but a small quantity of internal memory can also be used instead. After a frame is encoded, it is sent into UDP packets to the network at gigabit speed. This FPGA contains a UDP/IP network stack that receives commands and JPEG encoded video. It is connected to 4 high-speed hardware JPEG decoders working in parallel. The decoding throughput is up to 352 megapixels per second or more than two 1080p 60 streams. After decoding, the video is sent to a HDMI DVI output interface where the video timings and clock is automatically generated for each resolution. And now the second display shows the same cloned image as the first display. Now we will see the same procedure on the real system, where a PC display is showing a 1080p 60 video. At the bottom left corner, the system's command and control application is running, and the start button is pushed to direct the first board to start encoding and send the output to the IP address of the second board. At the same time, the PC application will configure the decoder board to generate 1080p 60 video timings and start decoding the encoder's video stream. Here you can see the control application interface. This is used to demo the underlying control API of the broadcast system. In the upper left corner, the detected resolution of the video input is shown. In this case, Full HD at 60 frames per second. To the upper right is a slider to control the quality factor, an integer from 1 to 100 used for JPEG encoding of the input video stream, as well as a chroma subsampling choice. At the bottom, there is a graph that updates with the bandwidth usage every second. And now let's take a look at the application encoding a real Full HD video stream. We can see at the bottom how the parts of the video with different complexity use more or less bandwidth, but always around 100 megabits per second. The quality value is set at 65 and subsampling is 420. These are very good settings for movie scenes. In this sample video, the images vary greatly from scene to scene, and the compression graph shows a higher variation. As can be seen, the bandwidth depends greatly on the image being compressed. We do not recommend using JPEG quality values above 95, which already is pixel perfect for the human eye. Also, values below 20 degrade quality very fast, while the bandwidth usage is only a little lower. As such, the quality boundaries that are recommended for an optimal use of bandwidth go from 20 to 95. Subsampling 420 is used in Blu-ray videos and is best for movie content. Subsampling 444 preserves the full color fidelity and is best for PC desktops. This concludes the video broadcast demo. Thanks for watching.